Alright, here is the video guide for lesson 4.2.2. I actually forgot to put an introduction slide here, so we're just looking at the first problem. But today we're really going to focus on practicing our probability skills, finding probabilities. We have a problem using the area model, and then we're actually going to discover a new model, and we're going to compare it to the area model, and you're really going to be able to choose either model anytime we're facing a situation of chance, and you're going to choose just kind of which one you like more. All right, we had a little bit of a spinner investigation on Monday and Tuesday at the end of our lesson, and we see a spinner problem here now. And so what's happening here is the first letter that comes up on spinner 1 and the second letter that will come up on spinner 2. If the letters form a 2-letter English word, you would win. If they do not form an English word, then I would win, the teacher would win. And so we're looking, one, at are the outcomes of spinner 2 independent of spinner 1, meaning if we get an I on spinner 1, does it change the probability that you get a T or an F in spinner 2? All right, that's what it means to be independent. Does the outcome of spinner 1 change the outcome of spinner 2? And you can answer here in A. All right, and then we get to part B where we want to find the probability or make a probability area model. We did this on Monday and Tuesday to find the probability that we win the game. Okay, well, probability area model, it's going to look a little different than we saw on Monday and Tuesday because we have 3 letters here, I, U, A, and 2 letters here, T and F. And so when I make my probability area model here, and this is really sloppy, and I apologize, but we're going to have, and you can choose, but I'm going to put the 3 letters on the left and the 2 letters on top. So I have I have U, and I have A, and then I have T and F up top. And I'm going to split the table accordingly. And so I have 3 horizontals and 2 verticals, okay? And then just like we did on Monday and Tuesday, all right, well, I has a 1/2 probability, U has a 1/6, A has a 1/3, T has a 1/4, and F has a 3/4. So we're going to multiply in to figure out what goes in each box, okay? And then we need to find the probability that you win the game, that is, the student wins the game. And so you want to find the probability of, or really the combination probability of all the English words. So, you know, and I can give you one just to see, like, if you want this box here, IT, that would be it. That's one of the boxes you would need. All right, there should be a couple in there, and you want to add those boxes that would let you win, and so you can get the total probability there. Okay, then once you have your total probability, you can answer this question here saying, if you played the game 100 times, who would win more often, you or the teacher? So really, who has the higher probability, you or the teacher in your chart? Meaning the words or the letters that create a word or the letters that don't. Here's our first look at a tree diagram. All right, so it's just a different way to break up a probability problem. Okay, and we'll see this in this problem and as we work through it. Sinclair wonders how to model the spinner game using a tree diagram. So he draws this tree diagram on the left, and Sabrina says that can't be right. The diagram makes it look like all the words are equally likely. What is she talking about? Why is the tree diagram misleading? Okay, well, she's saying that it looks like I has the same chance as U, has the same chance as A, and T has the same chance as F, and T has the same chance as F, and all of it. And if we go back, that's not true. They are not equally likely based on the spinners, so we need to change the diagram. So what it says here in part B is use the tree diagram, reflect the true probabilities of the game, and so we want to write 1/3 on the branch for A because A had a chance of 1/3. We want to write 1/4 on the branch for T because T had 1/4, and we want to do that for all the T branches. All right, and then you want to fill out the rest of the diagram, labeling each line with the probability that you're going to get that letter. So then what you'll do is, according to the probability error model, you will find the probability of spelling the word at. Now examine the bolded branch on the tree diagram. How could the numbers you have written on the tree diagram be used to find at? Well, here's the little secret to using a tree diagram. We are just going to multiply down the branch. And so if A was 1/3 and T was 1/4, you're going to multiply down that branch, meaning 1/3 for A times 1/4 for T, and then you'll have the probability of spelling at the end here. Going on from there, does the method work for other combinations? So we're going to keep just calculating all of the branches. All right, we're going to calculate every single branch, IT, IF, UT, UF, AT, AF, and we're going to see is the probability the exact same as what we had in our area model, and hopefully it is. Find all the branches with combined letters that make words, and so you again are just going to find the probability of spelling a word. So you want to look at the probability of at the probability of all the other two-letter English words, combine them and see what my total probability would be, and does it match the total probability you found in your area model. Here's one of my favorite problems, and so we have this rat, Romeo, and what we need to do is figure out, they believe Romeo is smart, and somebody declares that they don't think Romeo is smart, he's just randomly selecting a path to choose. And so we need to read A very closely here, and it says, suppose that every time Romeo reaches a split in the maze, he is equally likely to choose any of the paths in front of him. All right, so really this is going to be a tree diagram, and we just need to label the branches and multiply down to figure it out. And so when they say it's equally likely that he chooses a path, you can see here in the first one, there's 3 paths. It breaks into 3 paths. Equally likely means that would be a 1/3 chance he goes in the top one, a 1/3 chance he goes in the middle one, and a 1/3 chance that he goes in the bottom one because it's equally likely he chooses one of the 3. You can see down here it breaks into only 2, and so that means there's a 1/2 chance he takes the top one, a 1/2 chance he takes the bottom one. You can see on top it breaks into thirds again, and so you'd 1/3 chance, 1/3 chance, 1/3 chance. Now what we need to do is we need to figure out the probability that he ends up in A and figure out the probability that they end up in B. And just like in our tree diagram, we're going to multiply down the branch. And so if you want to find one of the paths to get to B, we have 1/3 times 1/2. That would give me 1/6. But that's not the only way that we can get to B. And so we could do another path and do 1/3 and whatever we have here, and we could talk about the paths that lead to B. And then we want to add up all the fractions that lead to B. We want to add up all the fractions that lead to A. And then we have our probability that they end up in A, probability that they end up in B. And you can answer your questions below here. Same exact problem as number 4, just a little bit tougher of a tree diagram, a little bit tougher of a diagram because we're adding A, B, and C. But the same thing applies. You can see in the beginning it breaks into 2 routes, and so that would be 1/2 and 1/2, equally likely. You can see here this is kind of tricky, but it breaks into 2 routes here. It breaks into this route and this route, so that's 1/2 and 1/2 again. And then as soon as it breaks into 2 right here, so that would be 1/2 and 1/2 here. And then the top part, it breaks into thirds. So you'll have your tree diagram practically, and you'll just have to multiply again your branches that end in A, multiply your branches to figure out what goes in B, multiply your branches that go to C, and then add up all your C branches, add up all your B branches, add up all your A branches to find your total probabilities and see which one is the most likely for Romeo to end up in. Lastly, we have a learning log, and it's just a reflecting on which of the 2 models do you find the best for calculating, and hopefully you kind of have a favorite one, whether it's the area model or the tree diagram. If you have questions on any of the problems, especially these Romeo rat problems, just let me know. I'll make individual videos to help you out. And if you have questions, always remember you can email me.